Hi everyone, this is Mrs. GA, and today we're going to talk about perpendicular bisectors of triangles. So if you remember, a perpendicular bisector is a line that intersects a segment at a right angle. So that's the perpendicular part, and remember a right angle is a 90-degree angle, and cuts that segment into two equal parts. So this is the perpendicular part, this is the bisector portion. So a perpendicular bisector does both. Okay, so here I see triangle ABC, and we're going to see if we can use this protractor and ruler to draw the perpendicular bisector of segment BC. So the first thing you're going to need to do is find the exact middle of BC. So you're going to measure how long it is. So my ruler tells me that it's 6 inches. So I'm going to make a little mark at the exact halfway point right here. Then we need to make the 90-degree angle. So remember, you take your protractor and you move the little circle, this little middle point right over your dot, and you're going to try to line up this line with BC. So I'm going to try my best. It covers it up, but do the best you can. And then here we're going to mark where 90 degrees is, which is about right here. Then you're going to take your ruler and turn it the other way so you can make a nice straight line like this. Hopefully your line turns out a little bit straighter than mine. And then you draw your line. So this would be our perpendicular bisector, and you can show that by drawing a 90-degree angle and showing that these two segments are congruent. So down here we have a little bit more vocabulary before we move on. So 3 or more lines are considered concurrent if they intersect at the same point. So if you have 3 or more lines that intersect at the same point, we call them concurrent. The point of intersection is called the point of concurrency. So we're going to be coming back to this word concurrent and these words points of concurrency a lot in the next couple of sections. So now we're going to learn a new feature in a triangle, and that's called the circumcenter. So the circumcenter is the point at which the perpendicular bisectors of the sides of a triangle intersect, and which is equidistant from the 3 vertices. So you can see here that we have 3 perpendicular bisectors. So this is a perpendicular bisector. I see that because the 90-degree and the 2 equal parts. This is a perpendicular bisector right here, and so is this. So I have 3 perpendicular bisectors that intersect at the same point. So we call this point the circumcenter. So our circumcenter in this case is point P. And according to the circumcenter theorem, the circumcenter is equidistant from the vertices of the triangles. So these are your 3 vertices. So if you draw a line from your circumcenter to each vertex, those 3 segments are equal. So we can say that AP is equal to BP, which is equal to CP. So again, first you need to figure out where the circumcenter is, and then if you draw a line from the circumcenter to each of your vertices, those 3 segments will be congruent, and that's the circumcenter theorem. Okay, in these next few examples, KZ, LZ, and MZ are perpendicular bisectors of our triangle GHJ. So notice we have our 90-degree angles, and another thing we can do to help us is to mark our congruent portion. So those HL and LJ are congruent, GM and MJ are congruent, and GK and KH are congruent, because again, these 3 segments are perpendicular bisectors. So another thing we can conclude from this, since we have the 3 perpendicular bisectors that are intersecting, we can conclude that point Z is the circumcenter. Okay, so let's start on this first example together. So here we are given that ZG, so here to here, is 65. You can label that if you want. HL is 63, and ZL is 16. So they want us to find HJ and ZJ. So the first thing you notice is that since we marked up our triangle so nicely, since HL is 63, so is LJ. So we can find HJ using the segment addition postulate. We know that HJ is equal to HL plus LJ. So that means that HJ is 63 plus 63. So HJ is 126. So again, we were able to do this because we are told that ZL is a perpendicular bisector, which creates two congruent parts. The next thing they would like us to find is ZJ. Well, we see that ZJ is the distance from the point Z, which is the circumcenter, to a vertex. And using that circumcenter theorem, we know that actually this distance is congruent to this distance is also congruent to this distance. So again, our circumcenter theorem tells us that GZ is congruent to HZ, which is also congruent to JZ. And they're asking us to find ZJ, which is the same as JZ. So we can say, okay, GZ is congruent to ZJ. GZ is 65, so that's what ZJ is also equal to. So again, the circumcenter theorem tells us that the distance from the circumcenter to each of your vertices is going to be equal. All right, let's see if we can try this next example. We're going to do the same thing. We're going to start by marking up these congruent segments because, again, they are perpendicular bisectors. So this time we are told that ZM is 25. So you can try to mark that up if you can. Okay. We're also told that ZH is 65. And GJ, the distance from here to here, is 120. So first they would like us to find GM. So we know that these two segments are equal. So we can say that GM is going to be half of 120 because two equal segments means they're divided perfectly in half. So we know that GM is 60. Okay, the next thing they're asking us to find is the length of ZG, which again is the distance from the circumcenter to one of your vertices. So here we can do that same thing. We can show that this distance is equal to this distance, which is also equal to this distance, and we can show that using the circumcenter theorem. So we know that HZ is congruent to ZG, which is what they're asking us to find. We were told that HZ is 65, so that's what the length of ZG is as well. So you do have to notice that Z is the circumcenter, so we know that these three lengths are all going to be congruent. All right, let's move on to this last example together. So here they ask us to graph the triangle with the given vertices and find the circumcenter of the triangle. So let's start by plotting our points. So here we have -4, 0, 0, 0, and 0, 6. Like this. So this is Q, this is R, and this is S. So let's start by finding the perpendicular bisector of QR. So I see that QR, this distance, is 4. So I know that the exact halfway point is -2 right here. And I know that since this is a horizontal line, that the perpendicular line will be exactly vertical. So I'm going to draw in, I'll do a dotted line, my perpendicular bisector. So again, I know that it's 90 degrees because this line is horizontal and this line is perfectly vertical, and I counted these units and cut it in half. Now let's find the perpendicular bisector of SR. So I know that this total length between 0 and 6 is 6, so halfway will be at 3. And since this line is vertical, the perpendicular line will be exactly horizontal, like this. So the circumcenter is where your perpendicular bisectors intersect. So I can see that these two perpendicular bisectors intersect right here. And the coordinate of that circumcenter is -2, 3. All right, that is all for today's video. Thank you so much for watching.